Hey, good morning, good afternoon, everyone. Over the last 25 years, Solidworks has been reinventing industrial equipment design and manufacturing by streamlining the process and reducing development efforts. So in this webinar today, we're going to explore some of those tools and techniques that enable businesses involved in things like industrial heavy equipment, tool and die, packaging, automation equipment to gain a competitive advantage. By far and away, industrial equipment is our largest market segment, and I find it fascinating, Andy. It's all the stuff in the back that creates the stuff that is shipped out to products. So
yeah, maybe if I can jump in here for a second, just so everybody knows, if I look to my left, I'm looking at Tim. We are in the same room. We're separate.
Socially distanced.
Get out of here, you creep. But just so you don't think we're looking out the window or out in space or anything.
So with me today, I have Andy Rammer. Andy is a mechanical engineer from the University of Wisconsin-Stout. Sometimes we call that the Harvard of the Midwest.
The Midwest.
Usually makes that joke. But prior to joining us here at Hawk Ridge Systems, he spent a number of years in the secondary packaging industry, creating extremely high-speed equipment, very complicated stuff. I was at an open house and got to touch and watch these machines operate, and it was spectacular. I met Andy in a live session like this, I don't know, 10 years ago, probably now, a long time ago. And I remember Andy coming up, asking deep questions. He was significantly interested in speeding up the process. At the time, he had shown me a spreadsheet he developed using some API calls that allowed him to start projects more efficiently. If I remember right, it would do things like get a whole bunch of data and create copies and reassociate the references. So
yeah, so I'm a definite culprit of the programmer's mentality, right? Spend a week to write a task to automate a 10-second task if I need to do it more than once. Grew up in a maintenance shop doing maintenance on machinery, fab stuff, and when you do the same 5 welds, thousands of times, or drill the same holes tens of thousands of times, you try and figure out any way to speed up that process and reduce the required effort, manual work.
Since joining us over the last decade or so, Andy's learned a lot and has a lot of perspective, both on the industry and what he's taken away from the reseller business. So I'm really excited to have him share the presentation material he's developed. Thanks for joining us today, Andy.
Cool. Yeah, thanks, Sam. So a little introduction on Tim. So Tim is also a mechanical engineer, graduated from NDSU. He's been on the channel actually for 20 years now. Worn every hat pretty much that's available. It's no lie. Everything from tech support to training. I was part of that. Some of the classes that he trained, to consulting, to presentations. He's really, seen a lot with what the software can do across a wide range of different industries and implementations. We really connected when I came in. When I was in industry, I came in for simulation training, and he was the instructor. First he's an engaging guy. It's fun to talk, and he was into motorcycles, and I think I got my first one. I was a year in, and I'm just learning how to ride this thing and talking about the track, and he had to fire up a whole bunch of pictures of him doing wheelies and whatnot. So
it's a sickness. It's a sickness for sure.
Since then, joining the channel, he's really been a mentor to me in a lot of ways, from getting up to speed on product knowledge, as well as developing the soft skills and ability to present that you typically don't get from a person like me, an engineer sitting at a desk all day long. So really excited to be presenting with him today.
Hey, Christian, I had about 7 at one time. My favorite was a GSXR 600 that wasn't much left when I was done with it, but had a lot of fun with that. Actually, some other really good stuff coming in through the chat line here. Drew's interested in tracking changes, and Christian's curious about design practices with legacy models. So some of this stuff's actually baked into this presentation, and we'll use this as a template for further webinars. So do feel free to key in your thoughts there. It's always more fun when you're participating. So here's what we've planned for today, but we're certainly willing to course correct or change directions. But we wanted to share some of the latest innovations that we've seen in design software and the current trends.
Yeah, and with that, how that plays into your process, how you can capture and create concepts very quickly initially to make sure that you're on the right path, when you do get into the more detailed modeling stages.
I'm going to show you some ways to generate design iterations more easily, so you can speed up that process.
How we can rework some of those concept models. Concepts are typically very messy, so clean them up for production.
And maximize performance. And then finally, produce assets for production by leveraging that original design data during the process, intelligent automation. So a little bit about us. Some of you are new to us and new to Hawk Ridge Systems, it is our vision to bring you innovative design and product realization solutions. Our mission is to build a trusted relationship and help you radically improve the way you manage your product development cycle. And our commitment is to provide exceptional sales, support, training, and service to our valuable customers. You know, I think we kind of do four main things here at Hawk Ridge. We offer a line of software solutions, a very deep line of software solutions. I'll share a picture of that in a moment. We're also into hardware, 3D printing and 3D scanning solutions. We offer award-winning technical support with our team to help you out along the way, and then training, including a really new exciting development of partnership, strategic partnership with Solid Professor. So we now offer some self-guided training classes. This is a quick snapshot of that software portfolio. Really covers the gambit from design, manage, simulate to manufacture and everything in between. So we'll be touching on a number of these products today, but not all of them. If you're interested in any of these at any time, you know, check us out on the web or contact us directly. We'd love to learn more about your needs and potentially how some of these solutions could fit into that. So thinking about some of the innovations and trends that I've seen is CAD isn't good enough anymore. You know, that's just part of it, but we want our CAD system to do so much more. We want to be able to leverage that asset downstream, do things like analysis, inspection reporting, CAM programming, documentation for the shop floor, or maybe end user documentation.
Yeah, and it's not only being able to do those tasks, but also combining them using a single source of truth is something I hear very frequently in regards to a trend, especially within the last couple of years. So using that same data instead of creating duplicates and pushing it around.
Cloud enablement has become extraordinarily important recently, and we've seen that being done a number of different ways, whether that's companies continuing to use locally installed software applications and then using VPN connections back to network directories where they store their data. We've also seen a move towards cloud-based storage, and there's some tools there, as well as full-on cloud-based CAD applications that are being developed presently.
Anybody using simulation and following the enhancements in the tools has got to be excited about the generative design, specifically topology optimization. There's been a lot of enhancements on that. In past years when I would do simulations in the industry, I would literally print out sheets of a plate and pass them around to other employees and try and draw patterns and figure out what the best strength to weight ratio was and run a bunch of simulations. With these new generative design tools, you can literally give it that plate, run the simulation, and the software will tell you where material needs to be removed to optimize that strength to weight ratio.
3D printing is changing everything. No longer is that limited to prototypes only. We're seeing a lot of different tooling like fixtures being created, as well as end use goods. So got some examples towards the end to share on some exciting 3D printing.
Yeah, and then the kind of the modular design. There's a lot of same but different, and historically it's been handled by doing a save as on like the top level assembly and then another save as on parts below that. There's a lot of tools that have been developed and are ready for game time, I guess you could say, that allow you to build a rule set around what is able to be configured and make that accessible to any user or customer.
And then finally, connected business systems. We don't want to create bills of materials in one software and then manually enter them into an ERP system. Today, customers are beginning to expect that to be built in, whether that's single directional or bi-directional. Connected business systems. So those are just some of the main trends. So there's like some questions coming in.
Yeah, I'm just looking at those. So this one, is there Christian, I can take us afterwards, or I can jot your name down here and I'll send you an email. John, hardware updates. That would perfect question for tech support. I don't know about you, Tim. I don't really follow all the real specifics in terms of hardware.
John, I'm going to drop you I will upload our hardware guide that you can review and check out some of the latest developments. Cool. So what we're going to cover here for the next 50 minutes or so is the concept, iteration, detail, and production phases of the design. Now, one of the things that we should probably think about is what happens before CAD. I've certainly been guilty in my career far too many times of jumping into the CAD system early, generating parts and assemblies, doing a bunch of work only to find out I didn't understand some of the basic requirements of
get excited coming out of that design brief with very little information and jump right into CAD.
So maybe pausing for a minute and thinking about some of these topics like deliverables or goals. How are we going to be scored? What are the risks? Is there budget? What are the resources? How about people? How are we going to collaborate best, especially today? And then how would we track all of that? So, you know, after 20 years, I've kind of learned a little bit, maybe step away, put down the mouse, think about some of these things. And then, you know, how are we going to like store that kind of stuff? So this is a snapshot at a tool from Dassault Systems called Solidworks Manage, and it's an addition on top of PDM, and it provides, well, a number of different capabilities specifically to our conversation here, task assignment and project development. So here you can see a little Gantt chart complete with the dependencies, so we don't put the chicken before the egg, or maybe that's the other way, I don't know. But you can build out that project, and you can share that view with others. You can also attach files to these tasks. So it's not just a way to see what the tasks are, but it's a way to get at that.
Yeah, so attaching people, and like Tim said, it's a bolt-on to PDM. So you can take that actual file inside of PDM, you know, it's linked up in Manage, attach it to that task, and it follows different processes and different workflows along with that. You know, really there's a couple of different pillars that Manage does hit that offers features outside of what PDM does. Obviously, this is, you know, a project planning environment that you see here, but there's also different dashboards that you can build. That's when we talk about trends, you know, maybe not necessarily a specific industry trend, but you know, everybody's working with different pieces of software and browsing. Dashboards are great. You know, it puts that information right at your fingertips. Different BOMs and records. Bill of materials aren't always or don't only contain the CAD models that you're developing. They might create packaging materials. They need to include that stuff, and so you know, that's different item management that you can add to those BOMs, as well as, you know, additional process management, you know, being able to handle different types of engineering change processes.
Another view to this is through the 3D Experience platform. So this is entirely web-based, can provide the similar kind of capabilities. So tasks, Gantt charts, all that kind of stuff. Got a question, can we get a copy of the presentation? We'll even do you one better. Instead of just sending you the PowerPoint, we'll record all of this and then we'll upload it to our YouTube channel so you'll be able to watch it again or share it with a friend.
So to start off kind of the concept stage, you know, Tim talked about the project definition, and I would highly recommend before even jumping into CAD to do some sketching. I'm a terrible drawer, terrible artist, or engineers by trade. We don't think like that, but just getting things on paper really lets you weed out those bad ideas, and so they don't pop into your head potentially down the road. I think, Tim, when we were chatting earlier, you know, try and force yourself to get 10 ideas on paper, just set a specific number to it, you know, and put them down.
Andy challenged me to do that on a presentation a while back, and I wasn't keen on it at all. You know, I had a pretty good idea of what I wanted to do, and maybe I could do 2 others. But through that exercise, I don't know if it was 8, 9, or 10, but all of a sudden something significant popped out, and that was actually, you know, what we used for that presentation. So I really believe in that. I wasn't sold immediately, but I have been now.
Yeah. One of the other things too is pen and paper works great. Also, I showed you a picture there. I went and picked one of these Wacom tablets up. It was a couple of years ago. They're fairly inexpensive, a couple $100, but it really makes that. I guess I'm a gadget geek or a nerd. Just that user experience of drawing digitally, you know, makes it a little bit more fun and interesting.
Let's see. So I wanted to just chat briefly about some of the different modeling techniques that we see folks using. And in doing this, you know, a lot of SolidWorks users online, maybe this is basic, but for some of the folks that haven't taken to SolidWorks yet, we use kind of 3 main file types, and those are parts. So those are individual component models. There are drawing or assemblies. So this is a collection of component models and other assemblies. And then finally, drawings, where we create 2-dimensional representations of our 3D objects. These files are all associative, and what I mean by that is if I change a part, if I open an assembly that's referencing that part, I'm going to see those changes propagated through, making changes quite easy. Next, I wanted to describe the different modeling techniques and then give you a couple examples of what this looks like in practice. So the fundamental modeling process is what we call bottom-up. And in this, we take individual component models, we generate those, and then we assemble in an assembly by adding additional parts, creating mates or constraints between those parts, in order to build that full assembly. So bottom-up modeling, it's the fundamental. Another approach is what we call top-down, and here we kind of work the other way. Now what we do is we create features or entire parts inside the assembly. You'll also hear this called in-context modeling. Look at that piece of angle iron at the lower part of that frame in a different color. You can see here we're creating a cut based off the other geometry inside the assembly. I'll show you how to do that in just a moment and try to explain some of the implications.
Hey, Tim, if I could jump in, Josh asked a good question. Do you recommend bottom up or top down?
Ooh.
And so that kind of plays into, I think, some of the points that we're trying to get across here is there's not a one solution for every scenario. You know, when you come out of that, hey, we've got this concept sketch, depending on what type of product you're developing or what type of industry or what that specific design is, you might use one versus the other or a mixture of both of them, which we'll see in a little bit.
Yeah,
good question.
You bet. I love top-down modeling. However, it's very powerful, but with that power comes some implications of change and whether I'm using that in other designs. And I'll give you a couple live examples, and then once we get out into the iteration phase of the detail modeling phase, we'll actually show you how to remove those references. So it's like a standalone part. Another modeling technique that's become massively popular is multi-body modeling. When I look at that welded structure there, I think immediately that's a great multi-body file. So let's go ahead and let me show you these three different workflows and what it looks like inside SolidWorks. So, here I've got a bit of some industrial equipment here, and I'm just going to drag and drop from my library of fasteners. So this is Toolbox. This is a library of nuts, bolts, hardware, things like that. What you'll notice is as I'm dragging this around, inferencing over different circular edges, it's actually resizing the fastener. So that just makes it easier for me to drop it in. So this part's been modeled. I didn't actually model it. It's just with the library. And I drop it in. And then through the act of dropping that in, it's created some constraints for me. And finally, I can think about the end size or choose the different options for the fastener. So modeling, we model up the part, we place it in the assembly. We've got something called mate references on that part, and that allows it to snap into position. But I could drag one in and then, add constraints, things like coincident, parallelism, that kind of stuff. Now down here, I've already done that on this component model. In fact, if you want to see those mates, just so you can kind of better understand, there's coincident between these faces, and then a distance off the motor, and then a coincident back here. But we need to trim this part down. And of course, I could, write down these measurements on a piece of paper or something and then incorporate those. I think it's easiest to just edit this part inside the assembly. So let me go ahead and do that. Now, when I do that, it's going to change the appearance of the other component, just a visual indicator that I'm now editing this part here inside the assembly context. I'm going to sketch on that face. Then I'm going to come down here and I'm going to grab some of these edges, just grab that series of tangent edges and convert that back into the sketch plane I'm working on. And we'll finish that off by extruding a cut. We'll just make this cut go like through both directions. That arrow showing me the side that's going away, and we'll make it happen. So I know that thing's going to fit. I mean, that is precisely located. I located it right off the assembly. Here we can see the feature, the cut extrude that was added. We can also see this little indicator here. This is an external reference symbol, which is showing me the presence of reference outside this file. Now, I point that out because at times when we move to the detailed design, we want to remove those references, and I'll show you how in just a little bit. Maybe another workflow, just to start one from scratch or almost scratch, is I'm going to open up a new file. Here I've got some sketch geometry, and I want to show you that if I use weldment here, I can just run structural members right around these line segments. So I pick a few line segments, gives me a little preview. There's capabilities in here to do things like change the corner treatment, whether I want to do butted corners or mitered corners or add gap or rotation. Go ahead and go down this way. What you'll notice about this technique is it just automatically gets the trims for me. I don't have to do any work. Now, to finish this off, I might go in and add a few more features, like maybe a mirror or two here. And one more, and we'll have our design kind of whipped up. Now, if you're modeling shapes like this using conventional bottom-up approaches, I'd really ask you to take a look at that weldment approach. It's phenomenal. Oftentimes when I show folks that, they go, that's great, but I need individual drawing views of those structural members. No problem. Here we've got that. You can see I've already constructed exactly that. Complete with those individual views and the cut list down here. So good stuff. Now, just to show a couple of other examples of multi-body approaches, for mold design or master model, these same approaches work fantastically. So, when it comes to the different design approaches, I tend to favor multi-body approaches as my personal favorite.
For doing conceptual work, yeah, multi-body is great.
But to your point, Andy, there's a time and place for each one of these.
Yep. I'll also show you kind of another kind of mix of both of them in a little bit here. So when we talk about design, three things that we really think about are form, fit, and function. And using these different modeling techniques, we can take that concept sketch and build the form around what that is. But the thing that's still lacking, and that's difficult to typically communicate, is going to be function. And so another thing that's built into Solidworks is Solidworks Motion. Let me jump into the software here to maybe demonstrate some of those capabilities. So when we talk about movement, a lot of times in the past, I've taken screenshots and jumped it into Paint and drawn arrows or fired up Excel and built out like a timing chart. And, maybe people are able to interpret that and maybe they're not, but is there an easier way to do it? And absolutely, and that's going to be leveraging Solidworks Motion. A couple of different ways that you can do it. One would be just a basic animation tool. So there's different levels of this. And with animation, it uses a keyframing technique where you specify any kind of property on here. In this case, I'm just going to go 2 seconds. This part should be here. You'll notice that it creates a keyframe. And under that part there, that's going to be under the move. So I could do like explode steps or change the appearance of these. But then what I'm able to do is take this and play that through. And this, I can set up however complex or simple that I want. And you can see this model here is extremely, minimal. We don't have any cylinders in there that are moving that gating system, no sensors that are created there. And we don't need to invest in all of that detailed design beforehand. But that's just kind of the basic package. I've gotten pretty in deep into motion when I was in industry, right, doing some fairly complex stuff.
Yeah, I remember Andy, in that simulation class, explaining to me his needs to simulate these mechanisms that he's working on in order to understand motor sizing requirements. And I don't remember what you called that reverse slam dunk.
Reverse slam dunk, inverse kinematics is what that one is. And so,
how about in plain English?
Geez, that's difficult. So in plain English, you have a cylinder that would push something in a linear motion. Here we have a path that's leveraging two different inputs that we don't necessarily know what those are, but we know what that path that the end of arm tooling needs to follow.
So maybe giving it the describing the motion, the profile, and then understanding the forces.
Yep, absolutely. And so that's something that we're able to handle in SolidWorks as well. So here what I have is set up is just, a simple tool with a, kind of end of arm feature on here. And I have a path sketch drawn out that, I guess I probably should have made that a different color. Yellow is difficult to see. But I just have a path made on a point on the end of this mechanism. And I can define a path motor in SolidWorks Motion. I use a sensor on that sketch that measures the length of that spline. So I know that it's 1104 millimeters long. And with this path motor, I can just simply say, I want it to transverse that 1104 millimeters over 2 seconds, pause, and then come back. I can use different types of curve smoothing there as well. And when I play this out, what you'll see is it does go through that motion. But really, what benefit does that get us? That shows us, but we just have this path motor driving. That's not something we can actually physically put on this machine. So what I'm able to do is run that inverse slam dunk or kinematics, and extract the angular velocities at each of these motor locations across the, that whole full range of motion. With these result plots, you can simply export those CSVs, and then I can set up another motion study that removes that path motor, and then I use two different rotary motors at each of those locations and import those data points from that angular velocity plot. And what this allows me to do is then run this study from those two motors and extract based on, real life physics and material properties, weight, whatever I have on there, the required motor torques, which if any of you guys are using Allen Bradley motors or drives, I know it's a very common one. Go Out Motion Analyzer is a free piece of software that you can download and then import these motion profiles into there to correctly size those motors and drives. So with some, extremely basic models here, I'm able to, set up and run some simulations that validate, using Tim's techniques, the form, the function, as well as some of the validation, very early on.
Sharing that kind of stuff too with your clients, this is so powerful of a way of, this is how I'm going to solve the problem. It can really be used as a powerful sales tool and communication mechanism. Extending where Andy was at, validation has always been something I've been passionate about. I was exposed to these tools, a long time ago in college, and they've only gotten better over the years. So I want to just share with you a quick example of this little jib crane that we have here and show you what that simulation setup looks like and how you can do this in the design process. So here I've got the model partially complete. I'll go ahead and enable that tool set. Now, you can share this tool set around the office with a network license, so one could serve the needs of the whole design team potentially. We'll set up a study, and we've got a wide range of study types from static, fatigue, frequency, nonlinear, dynamics, just to name a few, wide range of studies. And these all run inside that Solidworks interface, so it's easy to use right during that design process. There I've applied some material properties to the design. And the next thing I'm going to do is disable some of these components. Now, I'm using a couple of different types of meshing elements, and those meshing elements can make the problem just run faster. It's an efficiency tool. So these surface bodies that I'm treating here, I'm just going to tell the software it's 1/8 of an inch thick without actually meshing through that thickness, makes it a little bit more efficient. Here we'll convert that large I-beam into a beam element type. Again, another efficiency tool. From there, we'll go ahead and locate the crane. So we'll fix this bottom face so it can't be moved. Now there's other ways we could have done that with virtual bolts and virtual walls, but this is good enough for our purpose here right now. And we'll go ahead and add a force at the end of the crane here in the direction. We'll make that 3,000 pounds. Now you'll notice the arrow's going the wrong way. Those visual cues make it easy to set the problem up the right way the first time. Next, we're going to mesh the model. Now, the mesh can be, this is where the math meets the model. I have a lot of textbooks I kept from college, but none of them have an equation for a jib crane. But they do have equations for simple things like beams, triangles, and that kind of stuff. So in FEA, we're basically covering the model, representing it through analytic shapes, and then solving a large series of equations.
It looks like you're running this now, Tim, so we can all take a break and go grab a beer or something, wait for this to finish up.
Not so fast. That was actually the runtime on this model, so it's pretty minimal. And just like that, we've got feedback on our design. Now you're seeing a scaled image here. It doesn't deform that much. In reality, it's only saying about 1/2 inch of deflection. But by scaling this up, it allows us to better understand how it moves, do a little animation. Now I'm going to go ahead and generate a factor safety plot. So I've learned how far it deflects. And I would recommend using the deflection values first. They're very easy to test and figure out. But we'll do a factor of safety. This relates the applied loads to the yield strength of our material. So in our model here, we've got a factor of safety of 1.6, meaning it could support 1.6 times that 3,000 pound force. Now my goal was to have a 5x factor of safety, so I'm a bit deficient. So I just pop right back into that design environment. It's the same window. I go ahead and I could make my changes, and I can go right back and update that simulation. So it could be really minimal effort, but by doing it during the design process, that's the real magic. Don't wait till the end. Figure it out. Test your assumptions early and often. I'm a big fan of the fail fast kind of mentality. I'd rather figure out that what I'm working on isn't right instead of continuing to pursue that.
Yeah, I think that's kind of a theme across this concept phase too, right? With the concept sketching, get rid of those bad ideas early on.
But go through them. Mm-hmm. Simulation can touch a lot of different elements besides the motion Andy saw, the structural I showed, but there's mold flow simulation where you can look at plastic injection parts and the filling, packing, cooling, port, all that. Got cooling, like flow simulation, CFD stuff, a whole number of different simulation tools.
Awesome. So that's kind of moving out of that concept phase. Now we've got a good direction on where we're heading, and it's time to maybe take, conceptually we've got rid of all the junk, and now we probably still have some ideas in our head, and we're starting to move into this model a little bit more. Now in the industrial, equipment, some designs might start at this iteration phase. And so really what we're going to talk here about more is how do we work with the CAD software to, generate new models, to iterate through those once we're have a direction kind of defined.
Hey, Andy, while I'm showing this, there's a question in here about the tablet and the touchscreen stuff. Could you see if you could answer that for Martin while I'm showing a little bit about ways that you could take an existing design and duplicate it so that you can repurpose it and be more efficient with the next one. So there's two tools I wanted to share with you. One's built into every version of SolidWorks. The other utilizes the SolidWorks file management tool sets, also known as the PDM. So here in SolidWorks, I have a design, and if you're just using SolidWorks, the best way to take an existing design and create a duplicate is through the pack and go functionality. So this is going to enable us to create an entire copy or a partial copy of this existing design. You've got options into what you want to include: drawings, toolbox, disable components, what needs to be copied. Here I've got a bearing. I probably don't want to copy that. I love Mandy's idea of a single source of truth, and if I'm copying purchase components, I'm kind of defeating that purpose. So keep that existing reference. I can come in and rename the files by just double clicking here and giving it a new name, or using like select replace. In this case, 699 was a part number, so we could just say I want to take 699 and I want to replace it with, I don't know, 700. Replace all. We can see the new names generated there. We can point it to different folders to save in, or create an entire zip file. And there's options to add prefixes and suffixes to your components. Now, if you're not using file management, I've seen a lot of users attempt to do this manual file management by appending rev2 to the file name. And while that kind of works, it's really not the best way. You will spend more time managing those files manually than you would utilizing a file management tool such as SolidWorks PDM. So I'm here in the PDM environment now. It's built into Windows Explorer, and it provides revision control, search, and security on our data. You're looking at an eDrawings viewer here, so I don't have to be a CAD user in order to view and utilize this data. Now, there was a question from Eric a while back about licenses required to access some of these tools. So
SolidWorks users.
If you're non-SolidWorks user, you don't require the same level of access as the SolidWorks user to the PDM. So there's viewer licenses for people who view only, and then contributor for non-CAD users that create content and place it in the vault. It's important to point out the vault doesn't only store SolidWorks files, it can also store any kind of file, like this inspection report I've got here. Anyway, I wanted to just show you what it looks like to store different versions real quick, and then we'll get into the copying. Here I've got a previous version of this file I can toggle to, and it remembers the relationship. Version 3 of the subassembly required version 2 of 3 of this frame component. It's great. Like I said, you can do this yourself, but you will pay for it in terms of your effort and time spent tracking all of those changes. So this is an old version we're looking at, out-of-date version. You can have users that are only looking at the latest version. We'll go ahead and access that again. So that's the version control without creating different files to store these versions. Now, what I wanted to share was this copy tree. This can make it really quick to generate a new project. So it's a lot like Pack and Go. In fact, it has some of the same basic capabilities in terms of what you can include. But here we've got the file management aspects. Do I want the latest version or the referenced version of that assembly? We can do things like rename parts, not just with like a select replace like I showed you earlier, but with actual serial numbers. So let's go ahead and replace all of my existing files with serial numbers. And here we can see the brand new serialized part numbering and assembly numbering. Same as before, I can choose what I want to keep. If there's components in here that I don't particularly want to copy, like these purchase parts, we can disable those and even check all of that in upon completion. So, PDM has additional capabilities to make starting that next iteration that much quicker.
Awesome, thanks, Tim.
You bet.
And we can see mine now. All right, we're good. So that's all well and great, but every single time that you're creating a new version or you're doing that copy tree, you're creating new files. And in this iterative stage that we're at, we just want to see some geometry on the screen, right? Making new files is cumbersome. Having to do a save as, come up with a clever file name instead of part 1, part 2, right? Distracts us from our train of thought and the development of our designs. So a couple of other options that we have here. First is going to be, a branch and merge, which was released in PDM in 2018. It really is designed to go through this iterative process and evaluate a couple of different ideas. So here we can see we just have, a bench assembly has this foam lounge cushion component as, a part of that assembly. Doing the branch off of that assembly, we can select, the cushion modification 3. We'll just type that in and choose which part we want to branch off. We'll select that foam cushion, and when we select branch, you can see that it creates a new branch 3 component. Now I've kind of, I don't want to say cheated this, but gone in and made a branch 2 already that you can see there's significant changes in geometry there. And simply by coming back to that part that was branched off into one of those iterations that I was considering, I can branch that back into the original component as a new version of it or a new revision, and all of the references updated appropriately in my assembly. So I don't need to worry about doing, a bunch of save as, and I have a full audit trailer history of all the designs that were, potentially contemplated using or evaluated. Kind of another one, to the point I was saying before, in terms of saving a bunch of components out every time. And this is something that I use very, very frequently when I'm doing design work, is virtual components. What you see on screen here is a representation of a typical bottom-up workflow. You create a part, you save it on disk, you create another part, you add that to assembly. In your SolidWorks feature tree, you see your assembly in 2 parts. Let me jump into SolidWorks here to maybe demonstrate, a couple of different workflows with virtual components. So you can see on screen just a typical assembly and a basic feature tree. And by going to File and Find References, this is going to show you or tell you where every single file in this assembly is located on disk. And you can see these all have, specific file locations. If I want to add a new part to this, but I don't know if I'm going to end up using it in the final design, virtual component is definitely the way to go. In order to do that, you just drop down the insert components and select new part. Choose the template that you want to use for that. And then it's going to present you with a green check mark. Now, this is going to leverage some of the top-down methods that Tim had talked about earlier. This green check mark is prompting me to select where do I want the front plane of this new component to be. What I'd recommend doing is just hitting the escape key. That's still going to add the part into your feature tree, but it's going to fix it and locate it on the origin of what this assembly is. Then we can simply come in and edit this part, and now we're adding geometry to a new component in this assembly, and we're not required to save it out on disk. So to demonstrate that a little bit more, I'm just going to simply draw, say, pretend we need to make a guard for this side panel. And we'll just ballpark this, that gets the point across. Maybe do a sheet metal on that, and that's pretty good, right? So now we've got this basic component, and it's still, virtual. It only lives or resides inside this assembly. Well, to add detail to that, we can, just like any other part, open this up, and maybe I want to add some edge flanges here. So we'll just rough this in. That edge, and say okay on that, and we can close this component out. We could add as much or as little detail as we want. Saving those changes still doesn't prompt you to save it out on disk. We can see the updated changes made in this assembly, and it's still going to be, if we come up to the File and Find References again, what you'll notice is that now these virtual components, it says save internal to assembly. So this component lives only inside this assembly. You can only view it or use it while this is open. Awesome. If we decide we don't want to use it, we just delete it out of the assembly, and it's not taking up our disk space. Another workflow of using it is if you have components and you are using PDM, such as maybe, let's just hide that one, this plate, and it's used across multiple machines. Maybe I don't want to revise it, but I want to test something else out. I can at any point in time take a component that is saved on disk and make it virtual. Just a simple right click and make virtual breaks the link to that external component, and now I can manipulate this, change the geometry without affecting the part that's released that could potentially have negative effects on other assemblies. If we think about this, go through, detail it, decide that, hey, this is a component that we want to use. Let's just show this one again. Saving it out on disk and treating it like a regular component is as easy as a right click and say save part in external file. That's going to prompt you where do you want to save it, and now it's going to be disconnected. You'll be able to reuse it across multiple assemblies in a collaborative environment, and it'll be treated just like any other component. So just to kind of recap that, with using the virtual components, really the only file as you're using those is going to be the assembly and any other parts that it's referencing. If you want to add geometry to that, you can simply drop down and say new part, which is going to add a new part in context, or embedded inside of that assembly would be another way to think of it. Or you can break the link to production parts just by making them virtual.
Cool stuff, Andy. Let me go ahead and grab control here, and I'm going to move into another component of this of the process, and that could be engineer to order systems. So you can build a lot of intelligence into a SolidWorks model. I've seen a lot of people do some amazing things in SolidWorks that create whether very complicated individual bodies, part files, or assemblies that leverage design tables is one way to build in automation. What else? You got equations, the references in sketch mode. Assembly layout sketches are another powerful way to build in intelligence.
I haven't heard that one in a while.
There's just like a million ways to do this kind of thing. And one way is Driveworks. It's another piece of software. However, it offers you a consolidated rule repository, right? You can put all of those logic and rules into a single place. It could have logic and rules that extend beyond what SolidWorks could do. For example, lookups. Maybe there's a value that causes the tool to go into a spreadsheet, and based on that value, look up some other piece of information. So Driveworks, it's included with the version of SolidWorks that you have today. There's something called Driveworks Express. And if you've been wanting to get started, try it out. There's a bunch of tutorials. I've seen users take Driveworks Express and automate small parts of their process very elegantly. But Driveworks doesn't have to stop there. There's a number of other modules. It could be that you're actually entering in some parameters that drive the whole system. Or maybe you've got salespeople that are entering this information. You can even put it on the web and have
customers.
Have your customers fill it out. And it goes beyond the SolidWorks data. You can also build, besides part assembly drawing automation, e-drawings, you can do PDF, Word, Excel outputs. All of these kinds of things can get automated. So here's a quick look at one example of Driveworks. Now, Driveworks has a number of different examples out on their web. They're a really great company. I've worked with them for a long time. They've been around my whole career.
If you guys are curious, you can just go out and browse to it. You don't need to, purchase anything. Just play around with it.
Yeah, there's the built-in Express. They also get a free trial. But to take a look at what the web interface might look like is here I've got a little cupboard, and I can go in and resize this, and it's bound, right? It won't let me make sizes that don't make sense. We can adjust the height and the width, but within extents that we're able to control. You can control the color of things. I think the dark wood looks best on this one, so we're gonna leave that alone. Got the option to set door styles. Let's go with maybe a shaker style, and then throw like shaker knob on there for the complete package. Cool. So now I can go to the results, and you'll notice it's doing a couple things. One, it's obviously configured. You saw the 3D model update, but it's also doing things like building up, a quote here. So it can create cover letters, bills of materials. Here's a previous quote from some configuration I did a while back on the same model. So here it's picked up on the username, created a quote ID, got a summary, imagery, you can view it in 3D. And then there are, the e-drawings that it sends along. So even if I'm not a SolidWorks CAD user, I can download the free viewer, I can view my model that way, or create, PDFs of drawings or other kinds of things. So just a couple of elements from Driveworks. I'm bullish on this tool. I think it's kind of underutilized. Oftentimes companies will go and create their own sort of automation, but sometimes it's easier to build on the top of the giants around us. Right? Another element of detailed design deals with efficiency and reclaiming that in any way, shape, form you can. A couple of these I wanted to bring to your attention are assemblies and flexible assemblies, and then we'll go back to that external references concept that I introduced a little while earlier. So here we've got a fun model, another piece of industrial equipment, a mold. And the way this mold was set up, actually, we get the whole motion out of it. So as I drag it around, we can see the ejector set working. You can even notice that this lifter is going to relieve the mold so the part can get removed, but it's all set up with the right motion. Now, we like to build lots of sub-assemblies in SolidWorks, and we do this for good reason, right? Why, Andy?
Well, I guess a couple of reasons that you would do it would be to, one, simplify the structure of the tree, minimize the number of top level mates. If you have 5,000 components, you figure 6 degrees of freedom,
Three mates
for each component, 3 mates for each, that can add up. Another reason that pops into my head is design reuse. If you have an entire assembly, you want to group something together, reuse that sub-assembly across multiple assemblies that's going to reference it. Another one would be downstream operations, purchasing. If you can create a modular group of components and have purchasing order that, create exploded views for, maybe an assembly shop floor to put that together, ahead of time, that's all beneficial.
Yeah, so performance, right? Number of top level mates has a direct influence on performance. And then, collaboration also are kind of some of the main ones that come to mind. But actually, I'd love to hear what you think in the chat there. You'll notice as I'm moving this, the lifter here is sliding left to right on screen. And this is all one sub-assembly. If I click on it, you can see everything here is highlighted as one assembly. Now, so in SolidWorks, when we add an assembly inside another, that whole assembly is treated as rigid. We're not solving the mates inside that sub-assembly, which oftentimes is good enough. But sometimes on complex things like this, we need to see that motion as well. So you'll notice this icon here has a slightly different appearance, match the what I showed you in the PowerPoint. This is a flexible sub-assembly. It's actually solving the mates from that assembly inside this one. So there's some performance implications. We like to lock these things up before we move to production as we move through that detail when we want to maximize performance. So we'll just uncheck that. Now it's solved as a rigid object, and I'm going to have the best performance. Now, visually finding those things is not fun, and Andy and I both found that if you use this search tool up here, and this can be handy for locating components, features, basically searching everything in the tree, but if you type in flex, it would find any flexible sub-assemblies that are inside that assembly, and there you go. Now, this component right here was designed in context, and we can see those arrows showing me that they were designed in context. You can right-click on the tree and look at the external references, and there you can learn more about the reference, what it's referencing, and sometimes why. So the sketch is referencing an edge used to develop that profile. Right? Basically, this lifter pin fit right inside its mating component. So what we can do is we can remove that reference after the fact, so we can capture them and then go in and remove that external reference. It's fun to use the search tool up here and set that to external references, and it'll find all of them that quick. And now I can redimension this, add new relations and dimensions to, well, ideally to fully define this object. Now, why would I want to do that, Andy? That seems like a little bit of extra work, doesn't it?
Yeah, it is extra work, but again, using collaborative environment, using components across multiple assemblies. If this component is defined in context of one assembly and you go to use it in another one,
if that assembly changes, it
updates. Yep.
So with that power comes responsibility. So I like to do lots of in-context modeling, but I'll just share with you a trick. Sometimes while I'm editing a part inside an assembly, instead of letting those relations get captured, I'll utilize the no external references. So then, I might convert some piece of geometry and it'll create the geometry, it just doesn't create that external reference.
And it still allows you to snap, Tim, right?
Yes.
It does allow you to snap, It just doesn't
create the reference.
For those that are SolidWorks users out there, it'll still let you snap, it'll show that the reference is there. It just doesn't actually show it yellow, I think, because that will indicate that it is going to be added.
So as I was putting this presentation together, I ran it by Andy, of course, because he's got good perspective on this kind of thing. And he said, Tim, you've missed the best thing. The troubleshooting tool I use all the time. You just jumped to the one part. How'd you know that part was the one?
I'm not going to scroll through the entire tree to try and find what was designed in context.
Right. So what we can do is we can right click at the top level of the assembly and go to external references. And this will list all of the external references in here. Now, another option, I prefer redefining. I think that's the best practice. But I do understand, sometimes you just want to lock them or destroy them and never have them come back again.
And I would actually recommend against locking them. Locking them is intended for, preventing it from changing for a temporary time period and then coming back and being able to unlock it and update it. With a lot of my customers, it's I guess what I've seen is very rarely, one, do they ever come back and unlock it and update it, and two, they just end up forgetting about it. So why not just break it initially and redefine it, clean everything up?
So, when I think about those three modeling approaches, bottom up is the most stable for sure. Top down's powerful, but has some complications. Now you have references between the parts, linked through assemblies. I like that multi-body approach because I can create references, but they're all kind of contained in that one part file wrapper. So for my money, that's a lot of times where I might start. But like you said, kind of depends on the time and the place.
Yeah, for sure. Thanks, Tim. We gotta keep moving pretty quick here, so I'll go through this. Again, when we talk about performance, a lot of enhancements in recent years to deal with performance. One of the biggest one is going to be the different assembly modes that you can leverage. So large design review has been around for a long time. What it allows you to do is load only a subset of data of the assembly. So you can see, typically these parts would all have features underneath them, and sub-assemblies would all have parts. With the large design review mode, it's kind of, it was intended initially for just that, doing design reviews, opening it up quickly with very limited capabilities except for viewing. In recent years, they've enhanced that and are now allowing you to do measure. You can do things like section views to be able to, interrogate interior designs. You can hide and show components, as well as in 2018 or 19, I think they introduced this edit assembly mode, which gives you even more capabilities. So in this edit assembly mode, you can actually add, change, remove any type of mating to locate components. You can add new parts to this. In this case specifically, we have the wrong pumps defined, and so we're going to simply come in here in this, ultra super fast mode. Instead of having to load up all that detail, we're going to delete those out. We're going to insert this new pump assembly, which correlates to our layout drawing here, and drop that into place. Zooming in on that, we can create our concentric and coincident mates that are required to locate that where it's needed. One final one that I'm showing in a bit is magnetic mates was another one that was added, and what that does is it leverages things that are typically mated together in the same orientation. If you were watching closely, you see that as we drag that in, it will automatically snap that component to a predefined ground plane, and then we have nodes on the different mating locations, which will essentially show a magnetic line, an attraction line kind of. And when you see that, you can let go of your mouse pointer and it'll snap everything into location where it needs to be. So highly recommend looking into the large design review mode enhancements in the most recent years if you are dealing with any type of performance issues. So kind of to wrap things up here, we'll move now. Our engineering change or our engineering design is done. We've gone through the concept, creating basic sketches, really defining our project, iterating through a bunch of different models and concepts for that matter. Talking about some of the detailed design, how we move that into a production environment, and now what? So, again, that single source of truth, talking about a collaborative effort, combining all the different departments. You saw on one of those earlier slides, we have solutions for, a lot of the different jobs or tasks or deliverables that are required to go from that design to manufacturing. Just for example, two of those, one, Solidworks Composer allows us to repurpose that engineering data to create things like assembly instructions or, interactive videos. Instead of trying to explain this stuff through Solidworks exploded views, which are made to be more of technical type drawings, this is like a snapshot that allows you to create annotations, arrows that are actually reference the physical geometry, the virtual geometry in that model and hide or show components dynamically. Another one is going to be Solidworks Visualize, that you can, again, import that engineering model, and it's, super high end and super fun to use. It's ruined a lot of my weekends. Creating renderings from those CAD models. You can see on the bottom of this slide, two images. One is actually a render and one's an actual picture from a photographer, and just clicking that over, we can see that the one on the left there, I've done that in live presentations and had people guess, and you really can't tell the difference. So
Andy, I watched a webinar a while back, and I'm going to drop the link right now into the chat area if anybody's interested, where colleague Mike Sandy, now with corporate, put together a comparison of real photography versus digital photography with Visualize, and it was pretty eye-opening to me anyway, I'm not a photographer, the effort that it took to develop the scene, to set up the lighting, to take the pictures and then edit them. The post-processing effort was significant. So check that out. That kind of an interesting.
Yeah, I saw that one too. That was super cool.
All right. Next up, I'm going to hop into another area of production, and that's CAM. Did you know that Solidworks comes with a free built-in 2.5-axis CAM tool that's powered by CamWorks? CamWorks was one of the first Solidworks Gold partners, and they offer machining capabilities, 3-axis, 5-axis, mill turn. They just added some EDM capabilities, a real full-featured CAM tool. So just to give you a look at what the built-in, if you're on subscription, you've got access to this, might look like, I'm going to use this little mold design. Now, when I think of CAM and molds, I think about like these inserts here with the complexity, the significant machining effort. But the reality is, when I look at the mold here, a lot of these parts are kind of plates with holes, a lot of plate work. So let's pop one of these open and show you the CamWorks approach. Now, whoops, shame on me, I didn't turn on the add-in before I got to my little segment. So you'll get to see that. We just add in that capability, and it embellishes SolidWorks with a brand new toolbar that's going to enable us to run and set up the CAM. Now, CAM programming can be done manually, where we actually pick edges and assign operations, or we can let CamWorks do some of that for us and then interact and train it to do it our way for next time. So some of the things that I would do in setting up this is I think a little bit about the machine. How many axes are available, what's the tool crib on the machine look like, which post processor I'm going to use. We do a lot of custom posts every month. It's a big part of our CAM business. We've got probably one of the most talented post writers that I've ever met. So if you do have CAM needs, post is going to be an important part of that, and we've got you covered. Next up, we'll take a look at setting up the coordinate system. So I'm going to just attach it to the center point of my plate here. Now from there, I'm going to have it extract machinable features. Now, this is a native SolidWorks file. Well, to some extent, there's a cavity in here, but it's a native SolidWorks file, but these don't have to be native. What it's looking for are not the features to build the model, but the features that will be machining. So things like holes, any pockets, that kind of stuff. So just like that, it found these different hole groups of different sizes, as well as these rectangular pockets. Now I'm going to generate an operation plan. So that's where we apply the logic to machine those features. On a hole group, do I want to do a spot or center drill, then drill, maybe even ream, or do I just want to drill the hole? You've got options that you can set up there. So just like that, it's got machining operations. Just to show you what this looks like, I'll have it generate the tool path, and we'll just quickly rip through a fast simulation. So you see it spot drilling, then drilling, going around doing my machining, and finally the rest machining or the cleanup. Now we can embellish this, right? Like for example, maybe I want to combine the operations, so it's not going from center drill to drill back to center drill again. We'll just have it combine these operations for me. So we'll combine the drill and the center drill operations, as well as any of the milling operations. Less operations, less tool change, or better. We can also do things like sort the operations into a specific order, so we can tell it, which order do I want to go in. Let's go ahead and do the face milling and then the drilling stuff first.
And Tim, I'm going to interrupt real quick. We do only have our last minute here. We will finish up, but just for those that have asked that weren't able to catch right in the beginning, we will be posting this. So the recording, you will be able to come back and watch it.
Yeah,
but
you bet.
For those willing to stick around, we'll wrap up. We've only got a couple more minutes left.
Here's a slew of some of the most recent 3D printed parts that I've been exposed to. We see a lot of folks starting to use 3D printing to aid manufacturing, fixtures, tooling. Here you can see some jaws on a linear actuator. This part here at the center of the screen is phenomenal. This is conventionally a collection of parts, but the pneumatics and the spiral bellows, when it inflates, it actually causes this thing to close. So it's all just one part, 3D printed. Brackets galore. This is a polyurethane mold for some PCB stuff. Different vents. In fact, some of these machines are now shipping with 3D parts incorporated right on. We print metals. These are copper induction coils for some heat treating. So, pretty cool things.
And to really wrap this up and tie everything together, here's just a real basic workflow that I've concepted out that talks about using PDM. We talked about PDM. There's a lot of things that it can do: search, security, revision, or kind of the big hitters that I think of when I think of PDM, but also with every file that's saved in the vaulted system, it goes through a workflow. And this typically relates to processes that you guys have implemented. And when we talk about, that single source of truth, leveraging that engineering data across these multiple products, we can create ties and connections between these other products. In this case, I have a basic engineering workflow on the left-hand side there, which our CAD data goes through that conceptual phase. You send it for approval. It's in that initial review state, and then we release it. Well, what I did is leverage some of the API capabilities to generate some automated tasks that get fired off that create a CAM component. And what this does is uses an insert part into part feature that gives the programmers or the machinists some, ability to manipulate that geometry in minor ways or, major ways, which would, ideally trigger an engineering change process. But they have their own files, so it's really protecting the IP from the engineering group. And then that CAM CAD file, as well as the NC file generated from CAM, will go through its own workflow. Now, another thing to highlight in this workflow that I think is pretty neat is that once that CAM file gets completed, now you have a Rev A CAM file and you have a Rev A engineering file. When that Rev A engineering file gets that change triggered, it goes to a change in process, and automatically, because of how I had this set up, it's going to move that CAM file to an engineering rev in process. So everybody in the company is aware, real time of the status of that component. So parts aren't getting manufactured at the wrong revision, anything in process they'll be notified on, etc. So I am building a video right now on this. I'm hoping to get it out next month. So stay tuned for that. Keep your eyes open.
All right, kind of wrapping things up. We shared a lot of different concepts and workflows that we learned the hard way, and I hope you find them valuable. I'd encourage you to, develop those efficient concepts, iterate your design as quickly as possible, try 10 things.
Yep, get through those CAD models, and then make sure you do invest the time in the detailed design and clean that stuff up, right? You don't want to come down, a year down the road. I ran across that frequently where you open up a model that I just had to get it out and move on to the next thing, and it takes me twice as long to figure out how I designed it, what I did to make those, potentially some of those minor changes. And then, as we just kind of hit on at the end, looking at some of these other tools that we can leverage to, repurpose that engineering data instead of creating duplicate files and sending them off to, other products potentially.
Kind of call to action time now. So if you're not using SolidWorks, hopefully we've shown you some tools and techniques that you could really benefit from. On our webpage, a number of different spots, you can sign up for a trial. The web address is right up in the link. We'll probably put that down in the description when we post this on YouTube. Also, there's a handout available inside GoToMeeting, and again, we'll put that in the description down below, a link to it with the 3D CAD Buyer's Guide that explains all the different bundles of SolidWorks, what's included, when you might want one or another. Really great handout and resource. So trials for new users, handouts. For existing users, I'd encourage you to continue learning. I still do. I attend one of these things probably twice a week, maybe more, depends on the week. We offer formal training today. We're doing that online, remotely, but still instructor-led. And we actually can provide you the software so you don't have to chew up licenses during the training hour. We have also announced a strategic partnership with Solid Professor. So you can now do self-paced tutorials on a wide variety of topics. I'm really excited about this additional training offering. It's something that's come up many times, and I'm so happy to be able to offer that. So that was an hour, Andy. We covered a lot of topics there.
Just over. We almost got it.
Almost. I want to thank you for working hard on this. These things aren't easy to put together, so thanks, Andy, and thanks to everybody for joining. I really appreciate you participating through the chat, and we look forward to seeing you on the next one.
Yeah.
All right. Thank you.